Okay, 2017 question 2. Two heat-tolerant DNA polymerases use a polymerase chain reaction are TAC and PFU. PFU has proofreading activity. It checks that the correct nucleotides are inserted during replication of a target sequence and then corrects any errors. The graph shows the temperatures used during a single PCR cycle required to amplify a target sequence using year 2. Okay, and we've got a straightforward graph really, although quite a lot of detail in it, and we've just got 2 lines with our key. Calculate the time taken for 16 copies of the target sequence to be made from one DNA fragment using the TAC polymerase. So this is all just about you reading from the correct bit. Okay, so we have, this is just one cycle. So you've got to find your TAC polymerase, which is your solid line, and one cycle takes us to here. So it takes 3 minutes. So it takes 3 minutes to do one cycle. Okay, that's not your answer because it's asking you to get to 16 copies and we're starting at 1. So after one cycle I've got 2 and then 4 and then 8 and then 16. So I've got 1, 2, 3, 4 cycles. So 4 times 3. Oh, where am I putting my answer down here? And answer obviously is 12. Okay. Identify the time period during which primers bind to the original DNA fragment. So you just need to know this. Your high temperature is your denaturing of the strands. Your low temperature is when you anneal the primers. And then your kind of middle temperature is where you've got extension of the strand using DNA polymerase. Okay, so here is where I have got annealing of the primers, and it's the same in both. Okay, you've got to read this down quite carefully. And to here. Okay, so that is 1.1 to 2 minutes. Okay, a scientist was planning to amplify DNA using PCR. State which DNA polymerase should be used and describe the advantage of using this polymerase. Now, you could actually go 2 ways with this one. So you could have said, right, we're going to use TAC polymerase. Okay, and we're going to use that because it takes less time. That would be a nice advantage. There you go. It takes less time to do a cycle. Or you could say we'll use TAC because if you look here, you don't actually have to heat it as much. So if you don't have to heat it as much, that is going to mean that you that's less expensive because you're not having to repeat it multiple times at a higher temperature. Okay. Or you could give the numbers and you could say that TAC only takes 3 minutes. PFU's taken 4. Or you could go down the right route of saying, actually, I think that PFU is better because it has this correction, proofreading. And either would get you the mark. Okay? Explain the importance of using heat-tolerant DNA polymerases in PCR. We have a point at which we're raising it above 90 degrees. And if we didn't have a heat-tolerant DNA polymerase, then it would denature at that temperature. That's what you're looking for. It doesn't denature when you raise it to the high temperature. And that's the mark. That's